So we're gonna move into an entire chapter on probability. And probability is not like when I say, "Are you gonna do your homework tonight?" And you're like, "Bro, really?" That's the worst joke ever, but I use it every year. Probability is the chance of something happening. We usually call them events. So what we're going to get into first is how probabilities are measured. So not any number can be a probability. When we come up with our probabilities, it's within this sort of like this range where 0, a probability of 0 means that it is impossible to happen. So like let's say I have 3 quarters in my pocket right now and 2 dimes. And I say, what's the probability I'm going to reach into my pocket and get a penny? Well, it's impossible. I don't have any pennies. So that's when you get a probability of 0. It means that it's impossible. On the other extreme, this means it's certain. So it's guaranteed. Now I'm going to talk about the types of numbers that we use for probability. When we calculate a probability, it's between 0 and 1. We don't have negatives. We can have fractions. We can have decimals. We'll have percents, but we don't have negatives, ever. And we don't ever have anything higher than 1. There's no such thing in probability as being 120% sure. You're either 100% or you're not. Everything falls within that range. And the closer you are to the right, the more likely it is to happen. So, have you ever heard of the word odds? Yeah. Like, what are the odds of this happening? The closer you are to the right, the better your odds are of that event occurring. Right here in the center, there's a picture of, I think those are dimes. They call this an even chance. Have you guys ever heard of like 50-50 chance? Like when you flip the coin? That means that it's equally likely for one to occur versus the other thing to occur. And the coin is the best example of that. If you only have 2 possibilities, there's a 1 out of 2 chance that anything could happen. And then, of course, as you get closer to 0, it means that it's not very likely to happen. So if I have a probability of 10%, it's not impossible, but the odds are not in my favor. So you have to kind of take that with a grain of salt when you guys interpret those things. Yes, it could happen, but it's not very likely to happen. So you can see right here we're rolling a die, or the dice. You can see where that falls on your scale of probability. So again, it's from 0 to 1. 0 to 1 is like the decimal value, but if you were talking percents, it would be from 0% to 100%. So all you would do is multiply those numbers by 100, figure out what the percentage is. So talking about what types of numbers could be probabilities, look at this one on the right here. It says, which numbers could be probabilities? Is it possible to have a probability of 1 over 83? Yes, that falls in between 0 and 1. How about negative 0.8? No, that's no good. 114%? No, that's awful. How about 0.05%? Yes. 4/3? No, 4/3 is 1 and 1/3, I think. So that one's no good. So you're going to have to do that on your assignment in the very beginning. It's going to say which of these could be possibilities. The other thing that we need to know how to do is convert between decimals, percents, and fractions. All 3. I don't care which one they give you. Basically, all answers that we get have 3 possible answers depending on how you want to write them. So I'll show you first how to go from a decimal to a percent. If you want to go from a decimal to a percent, all you have to do is take the decimal and move it to the right twice. And basically what you're doing is multiplying by 100. So 0.7 as a percent would be 70%. I have a question for you guys. Do you know how to say this 0.7 number? You know how like they have words to them? Place value? Yeah, 7/10. Think about what that says. 7/10. That is exactly your fraction. Now, if you didn't know that, like you could also go off the percent. The reason why it's called percent is because it's out of 100. So you could have, if you wanted to, taken your percent and just do it out of 100 and reduce your fraction. So when you reduce the zeros right there, it gives you 7/10 anyways. Now, what if what if I gave you a percent and I wanted to come up with the decimal? Yeah, it's the exact opposite. So from decimal to percent, you're going to multiply by 100 or move the decimal right 2 places. But if you're going to go backwards, do the exact opposite. So you can either divide that by 100 or just move the decimal left 2 places. So if I move that left 2 places, 1, 2, it would give me 0.05. This, by the way, this dot right here is because all numbers are decimals. We just don't put it. So I wanted to see where it was, so I could just take the decimal and move it left 2. So I have to fill in the 0. That's how I got the 0.05. So if you want, you can do 500ths, or 5% is 5 out of 100. 5 out of 100, what does that reduce to? Isn't it like 1 over, yeah, it's 1 over 20. So when we work with the fraction form of our probabilities, we always want to reduce the fractions. Are you guys okay with that so far? So from 0 to 1 are all the possibilities. We'll never have anything higher than 1. Never, ever have negatives. Okay, so I'm going to sort of skip that animation for a second. I'm going to teach you about 2 different types of probabilities today. When we just say the word probability, usually we're referring to what's called theoretical probability. On the test, you're going to have to know the difference between theoretical and experimental. Now, theoretical is basically what is expected to happen. There's no experiment that's actually happening. We just do the math, and the math tells us what is supposed to happen. Now, it doesn't mean it's going to happen, but it's what's supposed to happen. Now, when we calculate a probability, we always start off in fraction form. The way you write your fraction is, I always start with the bottom. The bottom is the total number of possible outcomes. So, for example, in the spinner below, the total number of possible outcomes are the total number of colors there are in the spinner. The top usually is the number of desired outcomes. We call them favorable outcomes in probability. It's basically how many things there are that you want to happen. So remember I talked about the coins in my pocket? When I say the probability of picking a penny, I want to pick a penny. So the top number is how many pennies I would have in my pocket. The bottom number is how many coins I have altogether. So again, usually when I do my probabilities, I just use the fractions. I don't convert them or anything. But I do want you to be familiar with all 3 versions. So let's answer the question below. It says, what's the probability that you spin the wheel and we land on a green? So let me show you how to write a probability. We go like this. We want everyone to know what we're calculating, so we could just go like this. That's how we write probabilities. So that right there means the probability of selecting a green. So how many colors are there? On your paper, 1, right?
Yeah.
Just like different shades of the same color. But on the board up here, it's 6. 6 different possibilities. We want to select the probability that's going to land on a green. According to my picture, there's only 1 green. So it's not very likely to happen. 1 out of 6 is not, you don't have a very good chance of that occurring. Okay, the next one says the probability of spinning the wheel and it's not going to land on blue. Oh man, I want it to be not blue. So there's still only 6 choices. How many of them are not blue? Yeah, it's the other 5. And there's 2 different ways you could do it. You could either count it up, count how many are not blue, or you could just do this. Anytime they say the word not, so let's say I do the probability of something that is not, what I would do is I would take 1 minus the probability that it is. So if I wanted to know the probability that it's not blue, I could do 1 minus the blue one, which still gives me 5 over 6. So that's just a formula. I don't know why they want you to know it, but I was going to just ignore it, but I just showed it to you. So whatever. Okay, so that's the spinner. Now we're going to talk about the 20-sided die. I think they play this and use this kind of die in some kind of board game or something. I forget what it's called though, but whatever. It says it's a 20-sided die, which is called an icosahedron. it says, what's the probability of rolling an even number? So this thing is numbered from 1 to 20. So for my probability, I want to do the probability that it's even. What would my bottom number be? Well, to start though, not the reduced form. There's 20 sides to this, so there's 20 possibilities. Out of those 20, how many are even? 10. I couldn't think of the word. Yeah, so 10 out of 20 means the probability is 1/2. So basically, if you rolled that thing, you'd have a 50-50 chance of getting an even number. Okay, the next one says, what is the probability of rolling a 13 or a number that's divisible by 5? Let's not do that one. Let's not do the 13 yet. I don't want to talk about or yet because that's a totally different lesson. Let's just say, what is the probability of rolling a number that is divisible by 5? So probability that you could do a number divided by 5. So there's still 20 sides on this, but how many numbers on there could be divided by 5? 4 of them. 5, 10, 15, and 20. So 4 out of 20 would be 1/5. What do you have a better chance of happening? Getting an even one or getting one that's out of divisible by 5? Yeah, so when you want to look at your what's the better possibility of occurring, I don't know if that's actually English, but I just said there. If you want to see which one is more possible, just look at the decimal. This is 0.5 and this one's 0.2. So 0.5 is a better chance of happening than 0.2 is. Again, because of that spectrum that we saw from 0 to 1. The further to the right, the better your chances. Okay, so I want to go up and I want to talk about, and I did this sort of out of order. We're talking about theoretical probability. Theoretical means what's supposed to happen. So we didn't do the experiment. We just said this is what's supposed to happen given these circumstances. So what I want to talk about real quick is we're going to talk about experimental probability, which is a little bit different, but I want to show you this. Where the heck does theoretical come from? It comes from the law of large numbers. Now, the law of large numbers says that if you were to do an experiment and you were to replicate that experiment, like not even, what do you guys think is a big number of experiments? Like, what's a lot of times doing the experiment to you guys? You think 100 is doing the experiment a lot of times? Okay, well, in math and in probability, we're not talking about numbers that small. When we talk about the law of large numbers, we're talking about into the thousands or even into the millions. Now, no one's going to be able to do, no one's going to do an experiment a million times. So what they have to do is they have to use computers to simulate them. And what ends up happening, unfortunately, I don't know why this, and oh, there we go. There's my animation. This is like for flipping a coin. This is an animation or a simulation of 250 coin flips. You can kind of see that in the beginning, it kind of it leans towards more one color, but the more and more we do it, the more and more it stabilizes to be a 50% chance. And again, this is only 250 flips of a coin. If I did this a million times, you'll see it start to stabilize even more and be more of like a 50-50. But in the beginning, it's not really even close. It's like it looks like 75% when it first starts. And I mean, just think about flipping a coin, you guys. Do you always flip a coin and get heads, and then the very next time you get tails? No, sometimes you'll get heads like 5 times in a row. Sometimes it'll land 5 times in a row. But if you do it long enough, in the end, it'll all stabilize, and you'll get an even number of heads and an even number of tails because of the law of large numbers. So that's where the theoretical side comes from. If you do it enough times, your probability becomes the theoretical probability. So we're going to get into the last part of this. We're going to get into experimental probability. But before we do that, I wanted to go into this for a second, because in probability they talk about a deck of cards a lot. So I want to go through and make sure you guys understand some things about a deck of cards. Do you guys know how many cards there are in a deck of cards? There are 52 total cards. That's important to know because when we do probability, that's going to be your bottom number. So there's 52 total cards. So I want to just, and I know for some people you might be like, oh, that's obvious, but Jack, Queen, and King, sometimes they're referred to as face cards. So there might be a question that says, what's the probability of selecting a face card? The reason why it's called a face card is because those cards are the only cards that have a picture of a person where you can see their face. So there are there's 12 face cards. Now you guys, you know these like these little symbols within the card, like that right there, and then the diamond, and this one and that one. Those things, they're called suits. It's spelled sweets, kind of, but it's pronounced suits. This one right here, it looks like a shamrock. It's not called a shamrock. It's called a club. The next one is called a spade. Then the other ones are obviously the hearts, and then the diamond. Oh, I spelled it wrong. What? Diamond. And for each of these, there are 13 of them. There's 13 hearts, 13 spades, 13 clubs. And then the last thing I want to tell you, and it's kind of obvious, if there's 52 cards, there's 26 red and 26 black cards. Now on our assignments, that deck of cards right there, it's on the assignment, so you could actually like look at it. But I don't know about AZ Merit all the time. Sometimes in AZ Merit they expect you to know stuff. So there it is. Now you have all that information. Now this still isn't experimental probability yet though. This is still just regular theoretical probability. Because we haven't done an experiment. So here's experimental probability. It's the same thing you would expect theoretical to be, except it's based off of the actual experiment. So experimental probability refers to the probability of an event occurring when an experiment was conducted and data was produced detailing the number of times an event occurred. So it's still kind of like the same probability though, except the only difference is it's based off the number of trials you did. And our problems, a lot of times, they're very clear on telling you the number of trials. They'll bold it and they'll underline it in the assignments. That's important to know because that's going to be your bottom number. So the first thing I want to do with this is I want to explain to you how to interpret this data. Do you guys know what frequency means? Okay, so this experiment right here, or this the data that's provided to us is based off of an experiment of rolling the die. So like dice. So this is the side that is showing. You roll the 1, you roll the 2, you roll the 3. The frequency is how many times it happened. That's what it means. So basically in this table, if I want to say like how many times did I roll a 1? I rolled a 1 15 times. Now, what you guys are going to have to know how to do on a test and on the assignment is you're going to have to know how to calculate both the theoretical probability and the experimental probability. So let's go back to theoretical for a second. What's the theoretical probability of rolling a 6? So it's just 1 out of 6. Now, if I was going to calculate the experimental probability, it's not necessarily going to be 1 out of 6. I mean, unless they did their experiment a million times, maybe it would approach 1 over 6, but we don't know what actually happened. Well, we kind of do because we have the data. So in experimental probability, we know the number of trials was 120. If they didn't tell you, couldn't you just add up all the frequencies? Right? The bottom of that table will tell you how many times they did it all together. So out of that, how many times did they roll a 6? So our probability is 26 out of 120, which reduces, I believe, to 13 over 60. Oh, 13 out of 60. So that's your basic difference. Theoretical is never going to change because that's what's supposed to happen. But experimental, like if I was to do the experiment again another 120 times, doesn't mean it's going to be 26 out of 120 again. It changes with the experiment. But if I was to do the experiment enough times, eventually we'll get two numbers that reduce to 1/6. So like if I was going to roll the dice in a computer program 1,000,000 times, we'll get close to 1 out of 6. And what I mean by that is if you look at the decimal, I don't know what 1 out of 6 is as a decimal, but if you were to do something 1,000,000 times, I bet you it's real close to whatever that decimal is. Maybe off by like 100th or even 1,000th. But that's what happens with the law of large numbers. Anytime you do it enough times, your experimental fraction basically turns into your theoretical fraction. And that's why we're allowed to do theoretical probabilities. Because it's what's going to happen eventually if you do it enough times. And that's where I need to stop. So that's basically what I need to teach you today. I need to give you your new packets. I'm going to do a better job of getting an answer key up because I know I stopped doing that because someone took it home